This animation is a typical water meter room with backflow protection. There's an RP for the sprinkler protection and a DCVA for the potable water protection. The reduced pressure principle backflow preventer offers maximum protection against back siphonage and back pressure by functioning as a modified double check valve with an atmospheric port between the two checks. This design ensures that the pressure in the zone between the checks remains at least 2 pounds lower than the supply pressure, allowing for effective protection even if both check valves become fouled. These devices are suitable for constant pressure use and are commonly installed in severe hazard environments. They come equipped with test cocks and gate valves for testing purposes and are available in sizes ranging from 3/4 inch to 10 inches. An RP, which is its nickname, is required to be used if water treatment such as glycol is used in the system, as it is in severe hazard. You will also notice that the gate valves must be outside stem and yoke in order to visually verify that the gate valves are in the open position. You may also notice that there are red boxes or tamper switches attached to the stem. If anyone tampers with the valves without permission, these tamper switches will set off an alarm notifying the fire department. Therefore, you must contact the fire department before shutting down or testing these devices. An RP must be tested annually or on installation or if it is moved. The atmosphere port or relief valve on a reduced pressure principle RP backflow preventer is considered an air gap rather than an air brake. 2.6.2.9 Air gap summary. Air gaps should not be placed in noxious environments and must be at least 25 millimeters high, with a height that is at least twice the diameter of the water supply outlet's opening. If this port or relief vent opening was 1 inch in size, the air gap would be a minimum of 2 inches in size. When firefighters are trying to suppress a fire, they need to boost the system by attaching to the Siamese or fire department connection. After using this standpipe system, it will drain backwards to the check valve. The remaining water left in the leg between the check valve and Siamese connection can be drained through the ball drip. Remember, there is glycol or water treatment in this system, hence it's wise to collect any possible leftover glycol when it drains. Now let's move to the water meter bypass before addressing the double check valve assembly. The water meter bypass should have a minimum of 3 normal gate valves surrounding it. On larger buildings, the water meter is usually called a compound meter, which consists of 2 meters. A positive displacement meter runs while the demand is low, while the turbine meter runs during high demand. Most larger water distribution pipe systems are usually welded stainless steel due to its economical price compared to copper. Some systems can be Victaulic, copper, or plastic pipe, depending on the mechanical engineer's specifications. Moving to the left, you will now see the DCVA or double check valve assembly. A double check valve assembly DCVA is a type of backflow prevention device designed to protect potable water supplies from pollution due to backflow. The DCVA is primarily used for premise isolation in a commercial building. It is rated as a moderate and also a non-health hazard, meaning it's designed to prevent pollution or non-life-threatening conditions, not contaminants. It consists of 2 independently operating check valves arranged in series, along with tightly closing shutoff valves on either side of the assembly. This configuration allows the DCVA to effectively prevent backflow under normal operating conditions. The key features of a DCVA include 2 check valves. The 2 check valves work independently to ensure that if one valve fails, the other can still prevent backflow. This redundancy enhances the reliability of the device. The shutoff valves allow for isolation of the DCVA for maintenance and testing without disrupting the water supply. DCVAs are equipped with test cocks that enable the testing of each check valve to ensure they are functioning properly. Regular testing is essential to confirm that the device is effectively preventing backflow. DCVAs are commonly used in situations where the risk of backflow is moderate, such as in irrigation systems, fire protection systems without glycol, and certain industrial applications. They are not suitable for high-hazard situations, where more robust devices like reduced pressure principle backflow preventers would be required. Thanks for watching, and remember, it's in the code.